Hello! Today I'm going to show you how to find the nth term of a quadratic sequence. So first off, what is a quadratic sequence? It's a sequence where the second differences are all the same, or the first differences follow an arithmetic sequence. Those two things mean the same thing. Alternatively, it's one where the nth term is written as a quadratic. So we have xn, the nth term, is equal to an squared plus bn plus c. So this is a quadratic expression, and this is the nth term. What we're saying by this is we're finding the nth term of the sequence x. So this is the position, this is the sequence. So what's our first step? Our first step is to find the value of a. And we do that by finding the second differences of the sequence. And then a will always be half that second difference. So it's easiest showing with an example really. So we've got the sequence 1, 3, 7, 13, 21. And what we can see the differences are 2, 4, 6 and 8. So these are found by doing 3 minus 1 to get 2, 7 minus 3 gives 4, 13 minus 7 gives 6, etc, etc. And now the second differences are 2, 2, 2. So similar method, 8 minus 6 gives 2, 6 minus 4 gives 2. Because these are all the same, this sort of proves that it is a quadratic sequence. And a is always half of this. So a is half of this 2. So this tells us then straight away that a is equal to 1. So that's the method to find what a is. And to find what b and c are then, it's a little bit more complicated. So we have to make this little grid, and we're going to have each row, well the first row is going to be n, the second row will be xn, and the third row will be an squared, like that. So the first one is just the position, so we have 1, 2, 3, 4 and 5. The second row is the original sequence, so the 1, 3, 7, 13, 21. 1, 3, 7, 13, 21. And the third row then is we use our value for a and we multiply that by n squared. So n squared here would be 1 squared, which is 1, times by 1 gives us 1. 2 squared is 4, times by 1 gives 4. 3 squared 9, that one gives 16, this gives 25. The final row then is we're going to do this row, take this row. So we have xn minus an squared. So 1 minus 1 is 0, 3 minus 4 is minus 1, 7 minus 9 is minus 2, 13 minus 16 is minus 3, 21 minus 25 gives minus 4. And what we can see now is we're left with an arithmetic sequence. So a similar form to this one up here, where there's the same common difference. It's going down by 1 every time. So now we have to find the nth term for this arithmetic sequence, which I've done a video about. I'll link it in the stuff below. And what we can see here is this has got minus 1 as its common difference. So we know that d is equal to minus 1. And then using the formula for the other one, we know that the c part from there, not the c up here, but the c from the arithmetic formula, is going to be equal to the first term, which was 0, minus the common difference, so minus negative 1. And that will be positive 1 when this becomes a positive. So now we have that. We know that this part was equal to minus n, because it's minus d. So it's d times n, and d is minus 1. Plus c, which was the 1 in this case, that's plus 1. Now we take this part and we add it onto here. I suppose the c is the same across the two things. So yeah, we'll add it onto this part. We know that a was 1, so it's going to be n squared. So the nth term is n squared minus n plus 1. I'll show you another quick example, just to kind of build the patterns in your head. So if we have the sequence 10, 5, 3, 4 and 8. Looks kind of random, but we can prove that it's a quadratic sequence. So you see here this is minus 5 is the difference, minus 2, plus 1, and this is plus 4. So the difference here, the second difference, is 3, 3 and 3. Very nice. So this tells us then, if we have that a is equal to 3 over 2. We can write it as 1.5 if we want, but 3 over 2 can be just as useful. And the next thing then is to make our little table. So we're going to have n, xn, an squared, and then xn minus an squared. If you could just go straight away and write this line, you can do that. There's no reason why you need to do these first 3 lines, but it helps to write down the final line here. So position, we have 1, 2, 3, 4, and 5. The terms themselves then were 10, 5, 3, 4, 8. an squared, well a is 3 over 2, So if we square 1, we get 1, times by 3 over 2 gives us 3 over 2. 2 squared is 4, times by 3 over 2 is the same as saying, well, the 4, half of that is 2, times by the 3 gives 6. 3 squared is 9, so that's 27 over 2. And continuing this on, we get 4 squared, which is 16. Half of that is 8, times by the 3 is 24. And 5 squared is 25, times by 3 is 75. So 75 over 2. And now we do the second line. Do the fourth line even, sorry. So the difference between the second and the third. So 10 minus 3 over 2 is going to be 17 over 2. 5 minus 6 is minus 1. 3 minus 27 over 2. Well, 3 is the same as 6 over 2. 6 minus 27 is minus 21. That's all over 2. 4 minus 24 is minus 20. And 8 minus 75 over 2. So let's think 8 is 16 over 2. Difference between 16 and 75 is 59. So that's minus 59 over 2. Very nice. You only really need to do the first 3 because we just need to check that this follows an arithmetic sequence, but it should all be fine. If you do 5, there's no problems, no harm done. So now we find the common difference between this. Well, to go from 17 to minus 1, we have to do minus 19 over 2. And we'll just check that's the same all the way through. Well, this is minus 2 over 2. To go from minus 2 to minus 19, to minus 21, sorry, you do minus 19. So yeah, it should be minus 19 over 2 all the way through. So now let's think about what the c value is going to be. C is equal to this, the first term in the sequence. Sorry, the first term in this row. It's going to be the first term in this row, because we're looking at this arithmetic sequence now. Is 17 over 2 minus the common difference, so minus negative 19 over 2. This becomes a positive. 17 plus 19 equals 36. Divide that by 2 and we get 18. So overall then, we know that this was, the arithmetic sequence we just found was minus 19 over 2n plus 18. So looking at the nth term in total then, for the original sequence we got given, which was this one up here, the 10, 5, 3, 4 and 8, we have that xn is equal to an squared, so 3 over 2 n squared, minus 19 over 2n plus 18. Beautiful.